Hey everybody, we're going to be talking about atoms today in more detail. So just to get everybody on the same page, you probably know this, but atoms are small, very tiny in fact. All things are made of atoms. Carbon atom, which is moderately sized or on the small end of atoms, is less than 100 billionths of a meter in diameter. So if you cut up a meter stick into a billion pieces, a carbon atom is smaller than 100 of those pieces. So that's pretty small. Let's see. Everything is made of atoms. Again, everybody probably knows this, probably not a surprise to anyone. We're going to talk about elements, which are just different types of atoms. So an element is a pure material that's made of only one type of atom. We talked about this previously. There are currently about 118 different types of atoms, which means another way of saying that is you can say there are 118 different elements out there in the world that we are aware of or that we are able to make. Every element has a name. Every element has its own unique name, so you can tell it apart from the others. Every element has an abbreviation, because sometimes people just don't want to write the full name. The abbreviation has a more formal name. It's called the symbol of the atom. And the abbreviation or the symbol of an atom always starts with a capital letter, and the symbol will always either be just one capital letter all by itself. So for example, capital letter H is the symbol for one type of atom, or once we've run out of capital letters that we can use, if we need a symbol for an atom, it might have a single capital letter and then one or more lowercase letters. So another example of a symbol is a capital letter H followed by a lowercase letter e. So capital letter H all by itself, this one over here, that's the symbol for an atom called hydrogen. We'll talk a lot about that in a little while. Capital H with a lowercase e is the symbol or the abbreviation for a different atom called helium. So basically when you see a symbol for an atom, it's either going to be a single capital letter or a capital letter plus some lowercase ones. Every element has its own unique features, so that's what this is talking about. There are a lot of elements to keep track of. I said there's 118 of them, so somebody actually organized them. His name was, I think it was Dmitry Mendeleev or something like that. He was a Russian guy, long since passed on. He is given credit for organizing them the way that we organize them today, more or less. He did not organize them alphabetically. What he did was he put them into groups based on how they behave. So the idea is that even though all 118 different elements are different from each other, so they might have their own unique features, even though that's true, some of the elements are similar to each other. They have similar behaviors. So he tried to put the elements that are similar to each other near each other when he wrote the symbols down graphically. So I'm going to show you that here. This is, you may have seen this before. I know many of you have seen this before. This is called the periodic table of the elements. There are about 118 different boxes here. Each box is supposed to give you a little bit of information about one of the 118 different elements. Now, this particular periodic table does not give a whole lot of information. We are going to use a more detailed periodic table in a minute, but this is more or less the shape of the entire table that Dmitry Mendeleev is given credit for coming up with. Let's see. So the idea here is that each box represents one particular type of atom. So this box that I'm just circling here has a capital letter H, which means it's supposed to have information about the atom called hydrogen. This box over here has the capital H and a lowercase e, so that is supposed to give you information about an element called helium, etc., etc. So each box gives you a different piece of information about a different type of element. The reason that this table has this weird shape is that the idea is that if you are an element and you belong to one particular column. So I'm just showing you, I'm circling one particular column. All of the boxes, all of the elements in this column, they have certain features in common. Same thing with all of the elements in this column. So every element, number 22, number 40, number 72, number 104, they have certain features that are in common. Same is true for any of the columns, all of them. And that's why the boxes are arranged in a certain way, and they're always more or less kept in that way. The other thing is that all of the elements in each row also share certain features in common. So hydrogen, this one over here, and helium, this one over here, they're in the same row. They're in the first row, actually. Excuse me about that. They're in the first row, and because of that, they have certain features in common. We're going to talk a little bit about what those features are, but we're not going to go into great depth. All I want you to get is an appreciation for why this table of boxes has this weird shape. And it has the weird shape because people are trying to group the elements into areas where they're similar to each other. So the second row here, these atoms that I'm circling, I think there's 8 of them, they also have certain features that make them similar to each other. And that's true for all of the rows, and that's true for all of the columns. So keep that in mind. There are formal names for the rows and the columns. The rows are called periods. So the reason they're called periods is because certain features repeat over and over again with a certain period. Let's see, so the first row, probably not a big surprise, it's called period 1. So hydrogen and helium are in period 1 of the periodic table. What do you think the second row is called? You can pause it if you want, but I bet you can figure it out almost immediately. It's called period 2, this is period 3, etc., etc. So hopefully you understand what I mean by period 1, 2, 3, etc. The columns have slightly different names. They're called groups. So the first column of elements, or the first column of atoms, is called group 1. Second column, what do you think it's called? Guess what? It's called group 2, and on and on and on. These columns over here, they can have more than one name. I am just going to call them, let's see, this is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to call this group 13. There's another older way of giving it a different group name that we're not really going to go over, so don't worry about that. All I'm doing is going through this periodic table and trying to point out certain features that the table has. The other thing you will notice is that there's even more information buried in this table. And that the information is buried with the colors. So the idea is, if boxes have the same colors, then those atoms have other features that make them similar to each other. So hydrogen is kind of this light green color, so are these boxes that I'm circling over here. It doesn't really matter that you know what features they have in common. You should just realize that people are trying to stuff a lot of information into this table. They're trying to stuff information based on how the atoms are grouped in columns, how they're grouped in rows, and how they're grouped by color. So the green ones have certain features in common. These brick red colored boxes, they have other features that make them similar to each other and make them a little bit different from hydrogen, which is colored green. And usually those groups of atoms have special names. I don't really care that you know those names. One example, let me see, these brick red colored ones are called alkali metals. You don't need to know that, but just so you have maybe a slightly better appreciation of what's going on. These boxes, these atoms here, are metallic, and we'll talk about what that means later in the course, and historically they were given this name, so that's what that's for. These elements way over here, these light blue ones, they're called noble gases. They are at room temperature, they tend to be gases, and they're called noble gases for reasons that we won't go into. Again, you don't need to memorize these names. Please don't memorize the names. You should just realize that the colors are supposed to be telling you some piece of information. Another thing to point out, you may have noticed this asterisk over here. There's no symbol there. What is supposed to go in the place of this empty-ish box is this row of elements that I'm circling right here. You can see an asterisk that matches the one above. What this means is that all of these elements, or all of these atoms that I'm circling right here, they're actually stuffed into that box. And you can see the double asterisk underneath it. Inside of this box comes all of these elements that I'm circling at the bottom here. And the reason that people don't put them up here is because if you did, they would make the periodic table much too wide and it would be harder to read. So traditionally, people sort of rip out these two rows and they just present them underneath the rest of the periodic table, just to make the periodic table a little more narrow so it's easier to read. If you actually look up the periodic table on Wikipedia, sometimes they don't do that. They actually put these rows where they actually belong, and then the table looks really wide. But someone's just trying to be super proper there. So that's all I really want you to know about the periodic table. The idea is that it has this weird shape because atoms are trying to be grouped together based on similar features that they have.
Abule bene de costa nente, te ne